Hi and welcome to Pre-Calc 20 with Miss Verity. Today we're going to be looking at what I like to call 4.3a, which is completing the square. So when we talk about perfect squares is anything that is multiplied by itself. So x plus 3 squared is really x plus 3 times x plus 3, which if we were to multiply out would be x squared plus 3x plus 3x plus 9. So we get x squared plus 6x plus 9. If we wanted to multiply the other one, we would have x minus 2 times x minus 2, which gives us x squared minus 2x plus 4, which is x squared minus 4x plus 4. If we wanted to go the opposite way, so factoring instead, so we want to think multiplies to be 81, adds to be negative 18, well that's going to be negative 9 and negative 9, so x minus 9, which would just be x minus 9 squared. And then our other one, well, multiplies to be 25, adds to be 10, well that's going to be 5 and 5, so x plus 5, which would be x plus 5 squared. Well, what I would like you to do is take 5 minutes, try your hardest, try and think what you could put in those blanks that would cause you to have perfect squares. So something that will factor to give you your sort of perfect look. See if you can fill in those blanks. I challenge you. So solve this quadratic equation by completing the square. Like a goof, I put all the steps down here, but it's going to apply to the ones up there. So we've got a squared minus 6a plus 8 is equal to 0. So in order to complete the square, we're trying to force us to have perfect squares that we can factor. And so your first step is to get into the form x squared plus bx is equal to c. So I'm going to subtract 8 from both sides. And when I do this, I like to leave a blank because we're going to have to do that anyways. So I've subtracted 8, and I'm also going to put a blank on that side. Well, I want to think, what can I put in that blank that's going to give me a perfect square that I can factor? Well, in order to do that, we take half of the middle term. So our middle term is negative 6. If we take half of that, we're going to have negative 3, and then we're going to square it, which gives us 9. So in order to create a perfect square, I want to add 9 to that side. Well, what I have to do one side, I'm going to have to do to the other in order to keep it equal. Well, now if I factor it, so multiplies to be 9, adds to be negative 6, that's going to be negative 3. One thing to note, how does that compare to that value? Think about that. And negative 8 plus 9 is 1. Well, now I'm back to my regular old solving. Well, in order to get rid of my squared, I'm going to take the square root of both sides. And I know when we put in the square root, we get a plus or minus. We're going to split each piece, and we've got a minus 3 is equal to positive 1, and a minus 3 is equal to negative 1. Well, if I add 3 to both sides, I'm going to get a is equal to 4, and a is equal to 2. Well, there you go. There's your solution. So a is equal to 2 and 4. So this next one, so we want to get it into that x squared plus bx is equal to c form. So k squared minus 20k plus our blank, because we're going to be putting in blanks, is equal to negative 93 plus some type of blank. So again, maybe in the margins of your paper, you're going half of the middle. So negative 20 divided by 2 is negative 10. Half of the middle squared. So that's going to be 100. Well, in order to factor it, so multiplies to be 100, adds to be negative 20. That's going to be k subtract 10 and k subtract 10. So k subtract 10 squared is equal to 7. Again, what do you notice about that term and our half of the middle term? So now to solve, we're going to square root both sides. K subtract 10 is equal to, again, when you put in the square root, you get plus or minus. We can't simplify root of 7, so it's going to stay root of 7. Split our pieces. k subtract 10 is equal to positive root of 7. K subtract 10 is equal to negative root of 7. Add 10 to both sides, so k is equal to 10 plus root of 7. K is equal to 10 subtract root of 7. So in your squiggle brackets, you would say k is equal to 10 subtract root of 7 and 10 plus root of 7. All right, so this example, again, same thing. So b squared plus 8b plus some unknown number is equal to 8. So half of the middle is 4. 4 squared is 16. What I do to one side, I have to do to the other. From there to factor, well, multiplies to be 16 adds to be 8 is b plus 4. Again, notice our half of the middle number, when I divided by 2, was 4, and then I went 4 squared is 16. Notice those. Find a pattern. And 16 plus 8 is 24. Square root both sides. B plus 4 is equal to plus or minus. We can simplify our 24. That's going to be 2 root 6. So then when we solve, we would have b is equal to negative, b is equal to negative 4 plus or minus 2 root of 6. We can't simplify that anymore. That's our final answer. Our next example, so again, we want to get it into that x squared plus bx is equal to c. So x squared plus 8x plus our unknown number is equal to, well, if I subtract 9 from both sides, I'm going to have negative 13. My half of the middle is going to be 4. 4 squared is 16. So I'm going to add that to both sides. We're going to have x plus 4 squared is equal to 3. Square root both sides. And we get x plus 4 is equal to plus or minus root of 3, and to solve, x is equal to negative 4 plus or minus root of 3. So again, you could write it that way. You could also split and have your x plus 4 is equal to positive root of 3, or your x plus 4 is equal to negative root of 3. Isolate each piece, get your separate piece, but they mean the same thing at the end of the day. All right, so last one, solve by completing the square. So notice we're already in our x squared plus bx is equal to c form, so we don't have to move anything. Just because I like things in a specific order, I might move my brackets or move my statement just so I can have my blank. Okay, so we want to take our half of the middle. So I'm going to divide my middle by 2, and I'm going to cry a small tear because, you know, that doesn't reduce. It's not going to be a whole number, but that's okay. So that's our half of the middle, and then we're going to square it. So remember, when we're squaring, we're going 3 over 2 times 3 over 2, and when you multiply fractions, it's top with top, bottom with bottom. So we're going to get 9 over 4. So I'm going to add 9 over 4 to both sides. When we factor that, if you haven't noticed by now, our factors have ended up being our half of the middle number. So x plus 3 over 2 squared is equal to 9. This would be 5 and 9 over 4. Well, 5 and 9 over 4 is 29 over 4. So that's one way of adding fractions. Again, other ways to add fractions is you can get your common denominator. So I'd have 5 over 1 plus 9 over 4. Well, common denominator would be 4, so I'm going to multiply this by 4 and that by 4, and I get 20 over 4 plus 9 over 4 is 29 over 4. I'm going to square root to keep solving. X plus 3 over 2 is equal to, well, 29 doesn't square root, but 4 does. So that's going to be 2. Remember, we never want to leave radicals in our denominator. And so then, to get rid of that 3 over 2, 29 over 2. Because we've got that same common denominator, and in the end you want to have it as one term, well, they're both over 2, so that's really just -3 plus or minus the square root of 29 all over 2. Things to check would be, can that 29 reduce? No, it doesn't, so that is it.